Today we'll do a summary of chapter 5. So we're starting with the main formulas. So the gradient formula, which is y2 minus y1 over x2 minus x1. Basically, this is just the rise over run. Or maybe I could write it here. You can write it on the top, same thing. Okay, so write rise over run. Okay, that's the gradient formula. Okay, what else I have to include? And then we're going to find the midpoint. Midpoint formula is x1 plus x2, the average of the x, and then the average of the y. Average of the y. Like this, that's your midpoint. Alright, so after the midpoint, there is also the length of an interval joining 2 points, so which is this formula here, x2 minus x1 squared plus y2 minus y1 squared. So these are the 3 main formulas that you will use a lot in this topic. The gradient, which measures the slope of the line. The midpoint calculates the middle of the line, and the length of the line is the distance formula. Okay, which is an application of the Pythagoras theorem. Then we're going to do an example on this. So on this line, we're going to find the gradient, the midpoint, and the length using all 3 formulas. Have a try. Alright, do that now. Have a try. Should be pretty easy. You should all be able to use the formula to calculate the gradient, the midpoint, and the length. Okay, have a try now. Alright, so what we do is we're going to continue. Oops. Okay, so we're going to go to this bit. So all you have to do is write down the 2 points. -4, 2, 3, 6. And then we're going to label things. So you can call this x1, y1, x2, y2. And then use the formula. So we got y2 minus y1 over x2 minus x1, which is equal to 6 minus 2 over 3 minus -4, which becomes 4 over 7. Okay, that's the gradient. Midpoint, x2 plus x1 on 2, comma y2. Oh, it doesn't matter which one I write first. Okay, I could write x1 then x2, doesn't matter. Okay. So let's do that. So 3 plus -4 over 2, comma 6 plus 2 over 2, which becomes half, -half, comma 4 is your midpoint. Please be advised that the midpoint has a symbol capital M and the gradient has a symbol small m. Okay? No confusion. Alright, let's continue. Then we'll do the length, which is the distance formula. Distance is square root of x2 minus x1 squared plus y2 minus y1 squared. Okay? And then we'll just substitute the numbers in. What are the numbers? Which is these. So these are the numbers. So you do 6 minus 3 minus -4 square plus 6 minus 2 square, which becomes 7 square plus 4 square. 16 plus 49 is 15 plus 50, 65. So you get root 65. Okay? All that we found the length, the midpoint, and the gradient. Okay? So basically, the midpoint represents the middle of the interval. So this bit here is the midpoint, middle, right? -half 4, that's your middle, midpoint. And then we also found the length. The length is root 65. And the gradient, the slope, is 4 over 7. Okay? All right, any question? Pretty straightforward. Then we'll go, yep. All right, good. So If no other question, we'll move on to the next page. So these are the 3 important formulas. You should be able to get full marks for these sort of basic questions. Next, we're going to look at lines. So the lines are represented by equations. So we need to know how does each equation represent the lines. We need to know how to graph the lines. And there are 2 ways we're going to do. We can draw the lines using intercepts. So what we can do is we find the y-intercept by substituting x is 0. And we can find the x-intercept by substituting y equal to 0. So a line like this can now be graphed. So all you have to do is to find the x-intercept by substituting y-intercept first. So put x equal to 0. So you get 0 plus 3y equal to 6, y equals to 2. So that means on your y-axis, it crosses at 2. Once you get the y-intercept, we get the x-intercept. And to get the x-intercept, you substitute y equal to 0, which is 2x plus 0 equal to 6, which means x equal to 3. So the graph, the line will cross the x-axis at 3. And this is a very easy way to draw a line graph, because after you find the x and y-intercept, all you have to do is to join the 2 points together, and you get a straight line. That's the equation. You like to label, make sure you put arrows on both ends. Make sure you put arrows, and then label the equation, which is 2x plus 3y equal to 6. Very convenient. Alright, so we found the equation. So with this method, you can almost draw the line without grid paper, isn't it? So without grid paper, you can just locate the x-intercept and the y-intercept, join the 2 points. Okay, alright, so that's one method of drawing. There's another method of drawing called the gradient intercept form. We're going to draw the same line, but using the gradient and the y-intercept. Okay, in order for us to do this, we have to write it in the form y equal to mx plus b. To do that, we have to make y the subject. So we'll move the 2x to the other side. So 3y equals to 6, negative 2x plus 6. And then we have to divide by 3, which is equal to, divide by 3. All right, we'll continue. So we divide by 3, we get negative 2x on 3 plus 2, which is the same to you got from before, the y-intercept. This is your y-intercept. So your y-intercept is 2, which is b. Your gradient will be negative 2 over 3. Okay, that's your gradient. So now we can draw the graph, starting with the y-intercept of 2. That's your 2. And what the gradient tells us is that if I go 3 across, 1, 2, 3, we go 2 down. 1, 2. There's a point. Right? So you go 3 across, 2 down from the gradient. And once you get these 2 points, you can join the dots again. You can draw. So there's 2 ways. Using gradient and the y-intercept, or both the x and y-intercept. Both ways are fine. Okay, so these graphs can now be drawn, but there's some graphs shouldn't be, we have to use a different way of drawing because the equations are much simpler. So the graph will be very easy to draw. So just remember what they look like. These are the graphs with one intercept. So things like y equal to 2 is a horizontal line, cross the y-axis at 2, does not have an x-intercept, or the other one has an x-intercept but does not have a y-intercept, which is x equal to negative 1. So remember what they do, things like that, okay? So y equal to 2 is a horizontal line, x equal to negative 1 is a vertical line. And there are lines that look like this, y equal to 2x. So there's only one term, 2x. This one cannot be done using x and y-intercept because it passed through the origin. So for this region, when you have something like this, pass through the origin, you need one extra point. To get the other points, just substitute x equal to 1. If x equal to 1, 2 times 1 is 2, y equal to 2. So just get 2 points, 1, 2, and then you can draw the graph. So 1 across, 2 up, or you can just use gradient, right? Gradient is 2, or m equal to 2, b equal to 0, and then you can just join the dot. Just label 1, 2. Okay, so we know you pass through this point. Okay, so we've got all these graphs covered. So you have the easy one, horizontal, vertical lines, lines through the origin. If the line doesn't pass through the origin, you can either use the x and y-intercept approach or the gradient intercept approach. Alright, now we know how to draw graphs. We know how to find midpoint, distance, gradient. Then we have to move on to a bit more details. Okay, actually we've got one more thing I forgot to write down. A linear relationship is made up of points that form a straight line when graphed or when plotted. Okay, so what's a linear relationship? Linear means line, straight line. Alright, hopefully it's all done, so we can move on to the next page. Okay, next page is some algebra. So we did number plane, there's algebra. There's algebraic fractions, equation with fractions, inequality, simultaneous equations. These are all basic algebra that you need to master. Let's go through them very quickly. When we add fractions, make sure you have to make them the same denominator. Oops. Same denominator, so times by 5, top and bottom times the y, times by a, times by a. So you end up getting 10 over 5a plus 3a over 5a. Once they have the same denominator, you can add them, but you cannot collect like terms. So that's algebraic fraction. When you add, make sure they have the same denominator. What if you multiply algebraic fractions? You have to factorize and cancel out common factors. Okay, so the second one, there's a common factor of 3. X plus 2, 3 is common. And then you can start to cross things out. So x plus 2, they're the same. They get crossed out. And then the 2 divided by 2 is 1. 8 divided by 2 is 4. So you're left with 3 over 4 as your answer. Okay, algebraic fractions. Alright, it's important that we need to know how to simplify this because we can use it to solve equation with fractions. So this is an example of equation with fractions. So you have an x there we have to solve for. So one way to do that is to make them the same denominator. So we times by 5 times by 5. This one we do times by 2 times by 2. The right side no change because it's already 10. So you have to expand. So you get 10x minus 15 over 10 minus 6 over 10 equals to 9 over 10. They all have the same denominator. Let's write them as the common denominator, 10x. Now we can do negative 15 minus 6, which is negative 21 over 10 equal to 9 over 10. Okay? So the negative 15 minus 6 is negative 21. Now what we do is just get rid of the denominator by multiplying both sides by 10. That will cancel out the 10, which will leave you with a simple two-step equation. Okay? Once you do that, you can get 10x equal to 30, x equal to 3. How do you know? If you get it right, just substitute 3 back into the original. It should give you 9 over 10. But you could check that by yourself. Or you can, I'll just do a quick check. You can also check answer, check. So how do you check? You just go 2 times 3 minus 3 over 2 minus 3 over 5. You get 3 over 2 minus 3 over 5. So you get 15 minus 6 over 10, which is equal to 9 over 10. So we got it right. Okay, good. So what else I have to do? We can solve an inequality. So equation of fractions, these are the harder of the equations. You have to make things the same common denominator. Okay, let's solve a simple inequality. So we subtract both sides by 7 first, which you will get negative 2x is bigger than negative 6. But when you divide by negative 2, you must reverse the inequality sign. So x will be less than 3. Okay, good. So we drew the graph. We solved the inequality. Alright, once we did that, we should be able to do the next bit, which is simultaneous equations. Equation with two unknowns. Okay, so what we do is, there are two different types. There's elimination. Sometimes we add the two equations. Sometimes we subtract the two equations. Let's explore these. So the first one, they gave you a clue you're going to add the two equations because they're both, one is negative, one is positive, right? So if we add them, they will cancel. So if I do 1 plus 2, actually I'll write here 1 plus 2, you will end up getting 3x plus x is 4x. But the y get cancelled when you add them, equal to 16. Therefore, x equal to 4. Once you get the value of one polynomial, find the other polynomial. So I'm going to substitute that into 1. So you write 3x plus 2y equal to 6. X being 4, you can now solve for y. So x 3 times 4 is 12. Therefore, 2y is negative 6. Therefore, y is negative 3. So we've got both answers. Alright, good. So elimination are very convenient. When the numbers are the same, they matches, you add them. Or sometimes we have to subtract them because they are the same sign. Okay, so try the next one. Alright, good. Alright, let's continue. So we're going to subtract the two equations this time. You might like to do 2 minus 1, so you make the polynomial still positive. So 2x minus x equals to 5 minus 2. The y get cancelled, so you get x equal to 3. You worked out the value of x. Once you work out the value of x, you can find the value of y. Just substitute that into number 1, which is 3 plus y equal to 2. Therefore, y is negative 1. So we get a pair of solution. Okay, question. So it's very easy with elimination. Of course, sometimes you may have to change the equation in order to make the coefficient of one polynomial the same. Alright, let me see. Oh, we've done 3 pages already. Very good. We've got 2 more pages to go, 11, 21, and 22. What else are left for us? There's substitution method, and we're going to go through some other aspect of equation and line. And finally, we'll go through some part about regions. Okay, let's go through substitution method. Substitution method is, you use this method if one is the subject, which you substitute in the first one. See, y is the subject. So what you do is you write x plus whatever y equals to, substitute that by x plus 3 equals to 5. That's called substitution. So after that, what we do is we collect like terms, which we get a simple linear equation, 2x equal to 2, x equal to 1. Right? Once we find the value of x, we can find the value of y. Usually the one y is the subject. So from equation 2, we write from 2, y equal to 1 plus 3, which is 4. So you get a pair of solution. Okay, like that. Or you can write it as a point of intersection if we consider the two lines intersecting on the number plane. Alright, good. So we did that. What else are there? There's also another way to solve equation is to graphical solution to linear simultaneous equation. So we can also show the point intersection on the number plane. I think I drew them over here. So this is x plus y equal to 5. The other one is y equal to x plus 3. This is y equal to x plus 3. Okay, now clearly they cross at this point. They cross at this point, which is 1, 4. This is your point of intersection. Like this. Okay, good. Thank you. All right, we did that. Okay, what else are there? There's also gradient intercept form. Let's explore this. We just talked about it when we draw the graph. Let's review them again. Okay, y equal to mx plus b is the gradient intercept form where m is the gradient and b is the y-intercept. So we're going to find the gradient and the y-intercept of this line. For us to do that, you have to make y the subject. So to make y the subject, see this negative y. I like to do it this way. You write 2x equal to 5 plus y. After that, you're going to move the 5 over. So you subtract both sides by 5. And you get 2x minus 5 equal to y. Then you write y the subject, write y on the left, swap the sides. Once you do that, then the gradient and the y-intercept will be found very quickly. Alright, that's good. Let me ask the student. So Sorrentis, what's the gradient of the line? So good. How about the y-intercept? All done. Okay, so you should all know this because it's quite easy. Once you put it in this form, just read off from the equation. Okay, alright, excellent, good. Let's move on. Okay, now we're going to use this rule to find the equation of the line. Okay, so we know how to draw the line, but how do we find the equation given some information, such as the gradient and the point? So we're going to use this formula to find the equation. So for example, for this one, want to find the equation of a line with gradient 3, passes through that, 0, 1. 0, 1, we know because x is 0, that must be the y-intercept. Only because it's x is 0, right? X is 0. So therefore, I could just write y equal to mx plus b. That's the equation. But the gradient is 3 already. So write 3x plus 1 because that's your y-intercept. Okay? Any question? So we can find the equation fairly easily. Now the next question is, what if I don't give you the y-intercept? What if I give you a point instead? So it's the same gradient with a point. So in that case, you use this formula called the point gradient form. Okay? Use this formula when you don't have a y-intercept, but instead a point. So what you do is you write y minus x1, which is 1, equal to the gradient x minus 2. Very easy to use. And then you just have to expand, collect like terms. So 3x minus 6 equal to y minus 1. Move the negative 1 over, 3x minus 5. That's the equation. Okay, so remember this formula. You will use that more often than the other one because most of the time they don't give you the y-intercept, but they only give you the point. Okay, take a good note of that. And of course, you can always highlight important things. Let's use yellow. Oh. Okay. All right. Any question? Thank you. All right. Let's continue. We got one more page to go through. Then you can. Oh, there's not much time. Sure. Okay. Sit down. Okay. We've got one more page to go through. Then will just be scripture after this. Okay. Then tomorrow we'll do revision. You can get started with the chapter review. Got one more page to go through. Thank you. All right. One more page. All right. Let's start. Two lines are parallel if they have the same gradient. Oops. So the wrong one. Okay. Gradient. Conversely, if the gradients of the two lines are equal, then they must be parallel. Okay, so basically, if the lines are parallel, M1 equal to M2. For example, all of these have the same gradient. So we say all three lines are parallel. Two lines are perpendicular if the product of the gradient is -1. Okay, just remember the time symbol looks like perpendicular. Okay, the equal symbol looks like parallel. Oops. Okay, so what we do is, conversely, if the product of the gradient is -1, then they must be perpendicular to each other. Okay, what else are there? Okay, then we can do this question. Alright, we'll have enough time. Okay, we'll finish and then tomorrow we do revision. Alright, find the equation of line that's perpendicular to this. So you do m1 equal to 2. The second gradient must be times m1 must be -1. So you do m2 times 2 is -1. Therefore, m2 equal to -half. And there's your y-intercept. So now you can write down y equal to -half x plus 1. That's your y-intercept. Okay. Do we have time to do the rest? I think they are not too hard. Okay, we'll just give me 1 minute, we'll finish. Guarantee you. Okay, check if a point lies on the line. We have to substitute the point into the equation. Decide whether this point lies on the line. So you substitute 4 into y. Check whether it's equal to -3. So you get 6 plus 1. They're not equal. So you say, therefore, does not lie on the line. Does not lie on the line. Okay, just let me finish. This one will only take less than 30 seconds. Watch this. We got great inequality on the line. So x bigger than -2. You just go like this, open circle like this. X less than 1. You just go like this. Okay, this is graphing inequality on a number line, which can be confused with region. So this region is 2-dimensional, 2D. This is 1D, right? When it's 2-dimension, you have to go -2 with a dotted line, and you shade on the right, and y less than 1 is shade below. All right, get the idea? So there's inequality on a number line or region on a number plane. And then finally, we got combined regions. So if you want to combine both of these, then you just have to draw this like this. Let's draw this 1 and dotted line. So you just shade here, 1 and -2. Thank you. You can start the chapter review today and continue tomorrow. Thank you very much. I'll leave it on the board if you're still copying. Thank you for your attention. Finish. All right.